My name is Frank Messina. Over here we have,
Gabriela Maldonado.
Jeremy Harwood.
there you go. We are industrial engineers here, obviously. And this is our work that we did on the simulation competition for the Institute of Industrial Engineers. As President Florence said, the competition's held every year, and each year presents a different problem, but they're always really, really complex problems. And the whole point of the problem is to get really in-depth into it and analyze the problem and then use the simulation software called Arena, which is made by Rockwell Software. They sponsor the competition, that's why we've been using it. But Arena is a simulation program that lets you put in different variables and basically see how a plant is operating, the production outputs, things like that. The competition, the problem was released on January 26th, and the due date was March 20th. So we had a little under 2 months to work on the project and get it in and get it done. So. The problem this year is we were given that we're actually going to be working with unnamed Fortune 500 company. We were told that all of our solutions and recommendations that we were going to be giving would actually be looked at by this company and possibly implemented on their floor if they were good enough. So it was nice to know that we were actually working with something that could actually be used in the real world if, done well enough. We were given various information about the current layout that the plant was using, statistics of all their machines, things like that, how long processing times took, all the different kinds of things we were going to need to put into our simulation. And what they wanted from us was they wanted us to come up with recommendations for them. And they told us that their big thing was they were having a lot of issues meeting customer demand. So they wanted us to really look on that. They said they were having a lot of problems with their costs. Their costs were really high. They wanted us to reduce those. And they wanted us to just overall improve efficiency, profitability, and effectiveness, which is what industrial engineers do. So. Oh, yeah. This is our ambiguous product. This is an actual picture that was given to us with the problem, and we were told that this is what the company makes. They told us that for confidentiality purposes, they couldn't tell us what the company's name was, what the actual products they make, or even what it's related to. The only information we got was that they make everything from food to cell phones. So that's what they deal with. So that's the only information we got. So basically what we were told was the products that we were going to be making were called sections and units. Basically, a section is this darker gray outline here. It's the shell of the product. A unit is these lighter gray inserts with what appears to be a door, I guess. They didn't specify. But so basically you have a section, they get made separately. Then you have a unit which gets put into the section and an area called final assembly. So the sections are made separately, the units are made separately, and then they come together later on. This is an example of data that was given to us. A lot of the important things were given to us in tables like this. And the information you see here, it says TRIA 520, 120, something like that. What that is they already gave the data to us in a formula that Arena uses. TRIA is short for triangular distribution. And what this means is that when you put this in Arena reads this in as this station, say station 5, it could take anywhere from 5 minutes to 120 minutes. So 5 is the minimum, 120 is the maximum, but 20 minutes is the most likely that's going to take. So Arena reads that and goes, all right, I'll start putting out units, and the lowest number I can put on these units is 5 minutes. The largest number I can put on is 120, but on average, it's probably going to take about 20 minutes. So when you get your output data, all of the information is usually centered somewhere closer to 20. This is what Arena looks like itself. This is the Arena window that when you open the program, this is basically what's presented to you. We'll show you our actual thing later, but what you have here is, this over here is basically your toolbar. This is where you get all your little process modules, things like that. This down here is your viewer window. That allows you to see all the different variables. Like when you see ours, we have a whole layout. It takes up like a full page on this. And what this allows you to do is if you click on any one of these, it'll list every single type of that object down here. So instead of having to go and search around the entire page for what individual module you're looking for, you can just view them all right here in an easy to access panel. And over here, this after you set up your model and run it, working out all the errors that will undoubtedly come up. What it does is it gives you a report output that you can read. It'll tell you things like non-value added cost, which is costs such as like moving items between lines, transporting from, like if you have to ship something out, the transportation cost to get it there, that's such non-value added. Value added cost is something that actually adds value to the product, such as like if you're painting a product, actually assembling the product, things that actually physically add value to the product. It gives you, it adds these costs for you. It gives you cost of resources, which is Arena's word for a worker. So it tells you how much all your workers cost you, whether they were busy or on breaks. It outlines all things like that. It even tells you how many final products you put out. So Arena is a really useful tool when you're doing simulation things like this. These were the original plant layouts that were given to us with the problem. We were basically told that there's two different operating cells. Cell G, which is up here, that was the smaller one, and then cell A was the larger one. The main difference between the two was that cell G had cell G had one line for unit building, and cell A had 4 lines. And all that basically is, there's an area where the sections are assembled, which were those shells. There's an area where the units are assembled, which were the inserts. And then both of those products get transported to final assembly and get put together. Now, but with cell A, it has a section area and a final assembly area, just like cell G. But for units, there were 4 different build lines. So cell A can build a lot more units than cell G could. This is basically a flow chart that we made in Arena just to kind of wrap our heads around the way products were supposed to flow. Basically, these were all the unit and section build lines, but they're all separately. They would then move into getting put together in the final assembly area for cell A. And then over here, the cell G, they have the unit and section assembly areas, which then got moved into the final assembly. That's just kind of a flow chart, just to show you how the original layout was intended to flow.